Um, I plan to use this week 2 lecture to cover multiple inheritance. And then we'll go back after we introduce this, then we'll go back to do more on the rest of the content, such as JSON to object, as well as your what we call exceptional handling, and also the template function, template and function pointer and those kind of topics. Okay, so today we're going to talk about multiple inheritance. Let me give you a program and let you take a look. This is CPP 12, multiple inheritance. I have a class called core. So let me just do this 3. I want you to do a little bit of memory about what I'm going to show you, because I'm going to show you 4 different classes. They're related with multiple inheritance situation. So we have something called core. Core is a way I try to develop a more generic version of shadow object. So the core object contains 3 parameters that usually you put in the shadow. It's called host URL, class ID, and object ID. Essentially, this giving me information to uniquely identify every single object that I ever create. So core. So essentially, every single object should have a core as their base. All right. So it's core, and then I have another thing called JSON representation, which is a JSON value object. I'm not going to cover why I'm putting there. It's very important for us to implement a more generic way of doing JSON to object. All right, so that's why I want to talk about this class called core. All right, so think about core is a class which, remember, is on the top of the inheritance hierarchy. It has nothing after the name. That means it is not a derived class or anything else. Okay, so let's just keep the core here, and then let's go to person.h. Okay, so now I have another class. Now I kind of redefine person.h a little bit. So person.h will include core, which now this is what? It's an inheritance. Person is a derived class of core. So which means that the person class is going to inherit the host URL, class ID, and the object ID in that case. And okay, number 1, I want you to know it's a public. The inheritance mode is public. Public is probably easier for a lot of reasons, especially I want to do some kind of quick development. Public kind of gave me unrestricted access to everything I have in the derived. Okay, in this situation, I really want to be able to look at cores like an address, pointer, and things like that for the instructional purpose, of course. So it's a single inheritance because it only have a 1 class after that colon, class person colon, then you have a core. Okay, so I have this class called person. Now you know person is a derived class corresponding to core. All right, let's look at thing. Now I have a thing as well. So thing also has a core, and the thing similar to person.h, it is a single inheritance to core. So essentially the same thing. I want the thing has the property from the core, and then I basically have this this single inheritance from the thing to the core. All right. So now we're getting the next one. I call the robot. So this is the case, robot. So what is a robot? You can say robot is a thing, or maybe the robot has enough intelligence. Okay, assuming we can develop really fancy robot that we can treat a robot with the same classification as a person, has certain perspective of the person. Okay, assuming we want to do that, okay, let's not discuss the ethic perspective of this today, but the important thing is now you can see this line here. We have a class robot, and then I have a multiple inheritance, meaning that I have 2 classes, and inherit both from thing and from person. Okay, so that's the example we're going to work out today and a little bit into Wednesday as well. Okay, so I'm going to draw a picture about the inheritance hierarchy in this case. I should have done this earlier, but let's just do it now. Okay, let me create another slide. I want to get rid of this. I want to get rid of this. Okay, let's try to draw the inheritance hierarchy. I would say core, and then I'm going to put the outline, so it will be good. Okay, so let me make it a little bit bigger. Okay, I hope you can see this. This is core. And then I have another class called what? Person, right? And then I can create another class called thing. And then I create another class called robot. Robot is here. Let's assume robot is here. Okay, I have 4 classes. Now I'm going to draw the inheritance hierarchy. So person is a derived to the core. And then thing is a derived to the core as well. And then of course, what did I just do? Okay. And let me finish this picture first. And then robot is a derive of person. And then all right. So I finished this picture. Yeah, it looks more or less okay. Okay, so this is a inheritance hierarchy with those 4 classes I just joined. Okay, do you think this is reasonable to represent what we have? Or we just show you the code? Do you think this diagram represents what we have over there? Assuming you don't know what C++ multiple inheritance. This sounds reasonable, especially you're the Java programmer or your Python programmer. This sounds reasonable. No, not anyway. Okay, but this is, in fact, this is a wrong representation of multiple inheritance in C++. Okay, let me show you what this is. What we call, if I want to draw it this way, this is called virtual inheritance. The C++ multiple inheritance, the way I roll the code, I show you, it should looks like this. Let me tell you, now this is a tricky part why I don't like C++ multiple inheritance. Okay, so now I have 2 different picture. So this is a good picture for you to understand the difference between multiple inheritance and virtual inheritance. On your right is a multiple inheritance. On your left, this is called virtual inheritance. So just look at the picture. What do you see the difference, the critical difference between these 2 pictures? What did I try to represent using this contrast with this inheritance hierarchy? Yes. There's a 2 core, right? There's a 2 core object. Essentially, when I multiply inheritances 2, when I create a robot object, I'm actually going to have a 2 instance of the core object. Okay, think about it. You have a single inheritance, assuming a person to the core. When you create a person, you're not just create a person object, you create a core object as well. But now with multiple inheritance, when you create a robot object, you're going to have a two core object if you're doing multiple inheritance. If you're adding the keyword virtual in the inheritance relationship, then they're going to share a single copy of the core. Okay, that is a critical difference. It's hard to say which one is better, right? I mean, what do you think that in some situation we might think that, oh, this makes sense, right? For example, if I want to treat a robot, I want to say, hey, robot has the property about the person, it has the property about the thing, but I really think that the robot, the core, which is the host URL and those information, they should share this too, right? They should share this too. I mean, the other example, let me tell you, how many of you, I know all of you are students, so assuming everybody here is a student who pay the tuition somehow, okay? Somehow you pay the tuition, so your account is a student account. However, some of you might also be an employee of the university. So in the accounting system, you have also an account that is represent your paycheck that you receive from the university. So you think about that. You have a two account. One account is handling how you pay your tuition, but the other account is basically represent how the university pay you for your service to the university. So you have a two account. Okay, so you think about this. This is let me actually just draw the picture differently to see that this. Let's use this. Do this slide sorter, and I will use this one. Okay, this one I will call the account, and then this one I will say student. And this one I would say is employee. And this one I would say is you. And this one is also, of course, is account. And this one is account two. This is a student. And this is employee. And finally, this is you. Okay, now you see that I have a two different representation about your relationship about the account being handled. So my question to you is, do you think for the situation about somebody who is a student, who is also an employee of University of California, which representation, which is this, by the way, both of them are what we call inheritance hierarchy. So which inheritance hierarchy make more sense for the situation we're dealing with? Yes. Sorry, can you speak a little bit louder?
Yeah.
Multiple inheritance, why? That makes perfect sense, right? We have the separation because in two rows, you should have two different accounts, right? All right. So there's another hand here. Okay, so for accounting, it made more sense because the money, right, to separate. Well, let's actually change this a little bit. Let's change this account, not to accounting account, but to an email account. If it's an email account, which one do you think is make more sense? If we're talking about the account, it's not the financial account. It's just an email account, your Kerberos ID. Virtual it's better, right? I don't have to have a multiple account. Okay, for those of you who are Java programmers, think about within Java, how do you actually handle this situation? You can think about this. So what I want to address here using this example is that it's not always right or wrong about what is the right inheritance, virtual inheritance, multiple inheritance to use. But the thing is that sometimes you need to know there's a difference in the programming language like Java. They essentially they have a different way to handle multiple inheritance. They don't have multiple inheritance at all. In a language, programming language like a Python, when they call multiple inheritance, they really mean virtual inheritance. It's only like this, okay? Python, you don't have this, by the way. You don't have this. Python might be right because you have different way to specify this. Okay, I can include an account object in the student, for example. That might took care of some of the issue. Okay, so anyway, so number one lesson, I want you to see that the difference between multiple inheritance and virtual inheritance. Okay. So that's number one. So now let's go back to the code. Any question about the difference between these two? Okay, so let's try to run some program. Let's go to the program called testmi.cpp. Okay, look at here. I create an object. I create an object called my robot. Okay, based on this program. Let's try to do this. This was the code I had earlier. So let me get rid of this. So if you try to do this, say my robot .host URL. Okay, based on the code I show you about relationship between core, person, thing, and the robot. What do you think about this line? This line I put it here. Is this line okay? Do you think the compiler will accept this line? If I say my robot .host URL, let me just remind you where you can find host URL is under core.h. So under core.h, I have one of the attribute called host URL. So if you do my robot.host URL, guess what do you think the compiler should respond to that statement? Yes. Right. It is going to be that kind of issue. So that's thank you. Okay, yes. Okay, let's try to make. Okay, clean, make. Okay, you see that when they try to compile, they compile the program testmi.cpp. You see that they look at the message. I want you to read the message yourself. This is what they said. You see, that's exactly what we expect, right? It is a multiple base class subjects of type core. And then they said there are two of them. One is from the robot to thing and to core. And then there is one from robot to person to core. With this, they said, no, I cannot do that. Okay, but let's actually change this a little bit. We have multiple ways to get it to work, but let me show you how virtual inheritance will work. So let's go back to person.h. If you come to person.h over here, I can add, if you want to do virtual inheritance, I will do virtual over here, add the keyword virtual. And then I go to thing.h. And then I will say virtual. And then I just, to be safe, I also go to robot.h. I will say virtual and the virtual. Okay, I add the virtual for all the inheritance hierarchy. And now if I make a clean again, now everything compile. Okay, why? Because those two core has been consolidated with the virtual inheritance. And without virtual inheritance, you have multiple copy, at least two in this case. Therefore, the compiler will give you error. So that is the difference between virtual and non-virtual. By the way, if you have a virtual, if you don't have a virtual function, but you have a virtual base. By the way, this is called virtual base. When you have a virtual inheritance, that means one of your base class is a virtual base. When you have a virtual base, you need the table. And which we will look at memory layout a bit later. I'm not sure whether we can get to that. But when you look at memory layout, you will realize you have to have the virtual base. And in fact, interestingly, to resolve the virtual base, when you have a virtual inheritance, we want to resolve where is a variable host URL. You don't know that until runtime. The compiler time also cannot resolve this. We'll see why. Okay. All right. So let's go back to, let me remove this back to the original situation. So let me get rid of virtual for the moment. Get rid of this virtual and go back to the thing and get rid of the virtual. And finally, person. Get rid of the virtual. Okay, now I want to, now you can see that we're going to see the same kind of error again. Is because now I have two different comments. Yes. Right.
Thing and person, right? You need the inheritance virtual, but you have to make it virtual with the robot as well.
Okay, so I believe that's a good question. I almost want to say my answer saying that no, you don't need to work. You don't need to add a virtual. I just remember what I put. I said just to be safe. Because when you have those two, you specify virtual, it should already resolve that way. Because the core is need to be virtualized. Okay. So when you specify the robot to say person is a virtual, that means that if there's another inheritance path out of a person, then you're going to share that person as well. So that's why sometimes we decide to be virtual, then I just virtual everywhere. Okay. But the true answer to your question is I will write the program to test it out. Okay. All right. Excellent point. All right. So now let's try to make this things a little bit. How do I get this part to work? Okay. So the way to work, I already done the example here, is that pretty much I have to use casting. So casting is really useful tool for me to convert, because now if you look at the PowerPoint slide, I now have two different paths to go up. I have two different paths to go up. So the compiler is kind of confused if you're here, but somehow you move up to either the person or the thing, then the compiler will have enough information to say, well, which path I should take to help you to resolve this this ambiguity about the core. So that's why if you look at the code, if I do this, I do this way, the line here is essentially say I decide to casting to toward the person side, but I can also do cast with the thing side, which is a different core object. And this one is going to be 1002. Okay. In fact, what I want to do is that I want to print out the address. You will see that this two different core is going to be in different place. So let me try to print the address of I will use person and which is the reference I cast up. Okay, and I print the address. Dot host URL. And then I can cast up with this as well. Thing. Okay, I have a 2 host URL. I want to print the address in the memory. I believe this code should work, but let's try. Oh, wait a minute. What did I do? Oh, I make a mistake. Okay, that should work. Okay, now we're going to run the program. Okay, you can see that I'm printing now. Number one, the compiler error is gone when I do the casting. Either I cast person or cast thing. But furthermore, when I cast things differently, means one goes to the core. The first one is a core beyond person. But the second one is a core that beyond thing. And you can see that their memory address is different. One is ended with 278. One is ended with 1F8. All right. So now you kind of have some idea about where they are. Okay. You have a question? No. Okay. All right. Any other? Are you good? What's the difference? Now you know the difference about. There are two things. The difference between MI and EI. Okay, I hope you got it, at least virtual. The number 2 question is that under MI, that how do you get to different, it's the same class, but there are 2 instances in this case. And how do you get to different base class, which is you have a multiple copy. In this case, you have 2 copy. How do you do that? Casting up. Okay, always remember, I mean, casting is so important, so useful in C++ inheritance. Okay, when you do that, do casting, you can control where you want to go. All right, not trivial, but that's the way to handle it. Okay. All right, so now before I show you the virtual inheritance, I want to do one thing before I go there. I want to print out the important element, the address of the important element. We have done this before, but now it's more important than before. I want to print out the address of every single important element of this 4 class or 5 object. In fact, in this is a 4 class, but we have 5 objects. So let me write it down here. Max minus NW robot .h. So I'm sorry, I have to add I will call that integer robot number. I will add 1 element. Okay, so I can do this. All right, so I want to do one thing. I want to say, I want to have a way to say if it's a multiple inheritance, it is 4 classes, but it's actually 5 objects because core has 2 copies. If it's a VI, which is a virtual inheritance, we have a 4 classes and 4 objects. All right, so you will say, okay, this one with virtual inheritance, I'm less amount of memory, but with MI more memory. Well, the difference is that with the virtual inheritance, you need more V-table pointer, and which potentially adding some memory usage as well. So let's start to look at the memory address. What I want to print is the following. Okay, robot, colon, robot number. And then for core, I want to print whatever I have, host URL, the address of host URL. I should actually do this. And we're going to do the same thing for virtual inheritance to compare, then you will be surprised about the result. And then for the thing, I'm going to print sequence number. And then finally for person, I'm going to print, let's say the address of home, okay? Okay, let me double check. Did I misspell something? Thing.h is sequence none, not sequence number, sequence none. Okay, so then I'm going to go to person.h. What do I have? I do have a home. Okay, so this is a 4 address represent the where the object is. You know what? I changed my mind. Let's change this to SSN. I want to print the first attribute. That's probably make things easier. Okay, so I'm going to have this 4 address printed in the code. All right. So now I'm going to the test mi.cpp. All right, how do I print it? Can somebody help me? How do I print the address of robot number? How do I write this line? It must be somewhere here, right? I'm going to print something which is with n. What should I put between this pair of parentheses if I want to print the address for the robot number, sorry. What should I put in there? Yes. That's correct. Thank you. What's your name? Belen. Okay, Belen is right. That I will put my robot number. Excellent. Okay. Okay, the next one I want to print the core URL, but now we know we have 2 of them, right? So I actually have to include both of them here. Good. So I'm going to do next one is how do I print the thing sequence number? How do I print this? Anybody else besides Belen? Yes. You can do that, but from the outsider, you have to do a way involve my robot, because my robot is the object, right? You want to know the address of my robot. So you potentially can say my robot dot thing colon, but in this case, in fact, just remember this. This is because it has only 1 copy. There is no ambiguous situation. You can simply just say sequence number. This will work because sequence number, the compiler, no, there's only 1, right? There's only 1 sequence number in the whole inheritance hierarchy, even with multiple inheritance. See, the key difference is the robot number, I have 2 of them. So I need to do, not robot number, the host URL, I have a 2 copy, so I have to cast it. But if I don't have this kind of confusing ambiguous situation, then it will be okay to just say sequence number and then the compiler will, yeah, yes.
Just to be safe, isn't it? Can I still cast? Right?
Yes, you can cast. Yes, that's right. You can cast, right? Yeah, that's a good point. All right, so let's do this part. Now let's do the final one is a person, which is SSN. Let me change this a little bit. Okay, I like to change this way. I want to change the. Okay, let me change. I changed this SSN a little bit earlier, and sequence number looks like this. Okay, the difference. Okay, so I believe this should work. Let's see the number. If I do a make, And I'm going to, let me see, do I still have that? Okay, I want to go to robot.h, this 4, and I want to escape sh, and then I'm going to run the program dot test mi. Okay, I'm getting 5 different address. I'm getting 5 different address. So let's copy this 5 address over here. You will see what I'm doing. Okay, so I'm going to copy this 5 address here. The way I really want to copy is like this. The first one is a robot number, and the host URL, I have 2 of them. The first one is a thing or person. Anybody can remember the code? Let me pick the code. Forgot which one is which. The first one is a person. Okay. The first one is a person. So this is a person core, which is, did I already get rid of this? Okay. No, I want to get rid of this. This is a person. And then I'm going to make a copy. And then I would say thin. And that's the next one. And then it's this, it's this one. And then it's finally is this one. Okay, so now this is the 5 answer we have here. Yeah. Okay, you're right. Thank you. Almost forgot I make that arrangement, last minute arrangement. Okay, thank you. Thank you, Belen. Okay, so now I want you to help me with one thing. I want to sort this 5 number. Which one is the smallest? Which one of the 5 number is the smallest? 1, 2, 3, 4, 5. Which one? You should only need to worry about the last 3 digits. This is hexadecimal, the last 3 digits. Which one is the smallest? Which one? Is the sequence number, right? This one is the smallest. No. This one is the smallest, right? This one is the smallest. Okay. So I will ranking this. I mean, this order is important. I want you to know. This is number 1. Where's number 2? Number 2 is this one, right? Is that right? Okay, number 1, number 2, 158. What's the next one? This is number 3. And then which one is number 4? This one is number 4. Yes, that's correct. And which one's number 5? This one's number 5. Okay, so now we have a 5 object, right? We have 5 object. That's the order from the smallest to the largest one. So that on the top of the memory is actually what? Thing to the core. I would say just thing core. Right? Thing core that represent. And then the next thing is a thing. Okay. And then the third one is what? Is should be person core. And then the next one should be person. And finally is robot. That's correct? That's the order, right? Everything looks okay? All right, fine. If we found this is the smallest address, first. All right, so remember this one. So now I want to do a little bit different. We have only 10 minutes. I'm going to, let me just kill the whole thing. You know what? I'm going to copy test mi.cvp to test mi original.cvp. Okay, I'm going to modify the test mi to deal with virtual inheritance. Okay, so now I'm going to go into to person.h again, but now I'm going to add in virtual. And then I'm going to thing. Again, I'm going to add virtual. Okay, just to be safe, I'm going to robot, adding both virtual. All right, so now I'm going to, the program should be exactly the same. Still this, I mean, even as a virtual inheritance, I can still cast in, that's no problem. Okay, so I'm going to use the same program, but now everything is virtual. Let's try to make, oh, wait a minute. What did I do? Oh, I forgot to put a comment. Okay, so this is a robot.h. I forgot this view line. Okay, by the way, I should say this is multiple inheritance. All right, perfect. Make. All right, so I'm going to run the code. Now I have a 5, but notice that these two are the same because they share the same core. Okay, but let's try to copy this into the file I showed you earlier. And let's actually see what's going on. So I'm going over here. I am having now the address I'm going to put in behind this 5. I'm going to do the first one. Sorry, I make a mistake. Yeah, that's the first one. And this is the second one. And the third one. And the fourth one. And finally, the last one. Okay, again, I want you to compare this 5 address I just put. Which one is the smallest? Which one is the smallest about this 5 address? Really 4 address. Which one? Yes. The robot, right? You see, you already see the difference. The number 5 become number 1. Multiple inheritance is number 5. It's the highest address. But virtual inheritance, what? It became the top. And what's the next one? What should be the next one? This one, right? This is number 2. Right? This is number 2. What's number 3? Number 3 is here, right? This is number 3. And then this is also number 3. They're sharing number 3. And then this is number 4. Is that right? Does that make sense? I'm not sure. Okay, fine. Let me double check. Yeah, the number looks okay to me. Okay, so now if we take a look at this, is doing this the same thing, but with now I'm saying this is multiple inheritance. This is a virtual inheritance. And the first one, the smallest address is the robot. And then what should be the next one? The next one should be the person, it should be person, right? The next one should be person. And then the next one should be what? Person core. Is that right? Person core. And then it should be thing. Okay? So that's the 4 object. By the way, this one person core is also thing core. Okay, now I haven't explained to you why it worked this way. But already you see that it's dramatically different than the multiple inheritance in terms of the memory arrangement. In fact, I will say I'm not sure how much I can help you to understand this. The reason it's ordering, it has to do not only with the virtual inheritance, it has to share some object based on the concept virtual base. It also has to consider that this few classes might be derived or inherited from other classes that extended the current virtual inheritance. But the first lesson you should know is that they're different. And then, by the way, in between, there's a lot of vtable pointer. Let me actually just tell you that so far, if you notice this, the multiple inheritance thing and thing core need to be together, right? Thing and thing core, they're the same object, thing object. So they have to be together. Person core and person has to be together. But virtual inheritance, you see that it's, yeah, person and person core is still together, but it's a reverse order. The order is different. And thing is definitely a distance from where they are. If you look at the address, it's a bit distance. And it might be the same in a different way. But the thing is that in order for them to be able to connect to this part, I mean, what's happening is person to person should have a vtable pointer pointing here on the vtable. Okay, it has a vtable pointer to the table, but that table should have a pointer to help them to allocate this particular element core. And then the same thing for thing as well. So there you can start to imagine there is a complexity that's held the object to pointing to this way. The compiler cannot determine where to find the element. Okay, so that's what I want to tell you today. So just remember this. There are no, okay, I want to teach you 3 things today. Number 1, what's the difference between VI and MI? Hopefully you understand. Number 2, with MI, multiple inheritance, how do you casting up to find the right object? The third thing, which is the last part, is that not only we know about virtual inheritance, but also the memory layout for the virtual inheritance is very different from multiple inheritance, and for some interesting reason, which I will talk about that on Wednesday. Okay, see you on Wednesday. By the way, if I don't see you, happy Thanksgiving, okay? I might be here just by myself Wednesday evening. That's fine, okay? You should go home, enjoy your holiday with, yeah,